So as I previously told that I will illustrate some example for the simulation as well. So how we can use the simulation in the project selection. So I will take very simple example, and maybe more detailed example I will leave it for some other time. Okay, so for example, over here, as we can see in the lecture slides, we have seen a case of a project. Yeah, there was this very detailed case as well, and then for which I have also explained the calculation. But let's take a rather simple case for the net present value example. So $100,000 is the investment, and then on average we are getting benefits from the project about $25,000. And using a 15% hurdle rate and a 3% inflation rate, we have found that the net present value of the project is $1,939. So, so let's see if, how it looks like in our Excel. Okay. So in Excel we have like this. Okay. Okay. So for example, if I say that it's maybe I can make it a little bit bigger. If I want to evaluate it year wise, okay, year. So how we can create this model? So in starting from year 0 to year 8. Okay. Yes, here you can see that for year 1, 0 to year 8. 0 means this $100,000 investment, and $25,000 are the net annual cash flows from year 1 to 08, year 1 to year 8. If I go back over here, so the net cash flow. So if an investment of $100,000 was made, $100,000 was made, and $25,000 are the annual cash flows, positive. So negative and positive. So remember that the investment, that is the cash outflow, I am representing with the negative sign. The benefits from the project are $25,000, which I am representing as a positive sign. So we can perform the discounted cash flow analysis using the hurdle rate, that is the, in this case, in the interest rate, K is represented by K over here, which is 15%, I can put, and the inflation rate, which is represented by P or rho over here, and the inflation rate is represented by 3%. Okay, so in this case, the discount factors are is equal to 1 divided by 1 plus the discount rate, sorry, the hurdle rate or discount rate plus the inflation rate, and then power the year. Okay, so that is 1. So here it is. It maybe you can represent like this, and then I can copy it down. So which is again I made a mistake. I think some mistake I have made. So it is 15%, 3%, and then now it is 111. That is strange. And then, oh, okay, yeah. Because these values are constant, so therefore I will have to press F4 buttons with the E1 and E2, and then yes, then it will go like this. Okay. So this here is the discount factor. Okay, and now the net cash flows are, sorry, the discounted cash flows are equal to net cash flow multiplied by the discount factor. So it will be 100 minus $100,000, and the sum of this is, sum of the net cash flows is is equal to over here. So this is the net present value, okay? Net present value 1939.14, which is the same that we that the answer over here. So with this net present value is $1,939. Shows that if overall, if this project is run for 8 years, okay, over its lifespan of 8 years, we get a net present value of $1,939, which is greater than 0, which is a positive net present value. So therefore, this project can be accepted. Did anyone wanted to say something?
Yes, I have a question.
Yes.
What is the meaning of 15%?
Yeah, 15% is the hurdle rate. Hurdle rate. Okay. It is the interest rate at which you evaluate your project. Okay. It is the interest rate at which you evaluate the project. This interest rate can be considered due to many reasons. One of the reasons may be that for the starting of the project, you may take a loan from the bank. And then you have to, you may have to take a loan from the bank. So for example, this $100,000, it may be the loan from the bank, and then you may have to return that loan. So that interest rate may, which we are following over, which we are using over here, that may be reflecting the loan which you have taken. On the other hand, there is another meaning for that, is for the hurdle rate is also that by taking this project, you are taking a risky endeavor. Okay, you are taking a risk for this project, because in any project there is a risk involved, and then you may or may not get the expected benefits which you are taking, like $25,000. So if we have, for example, if you have this amount of money with you, you may otherwise have invested in some other more safer option. So that more safer option may give you some sort of profit. Maybe it is 15% profit like that, or maybe it is 10% profit like that. But by investing the amount into this project, you are taking the risk that you are foregoing some of the opportunity. So from the concept of the opportunity cost, from the concept of the cost of capital, we need to consider some sort of interest rates that we call as the hurdle rate. Okay, so this is the 15%. And then in addition, there is the inflation. Okay, so which is independent of your hurdle rate. Okay, so we also have to consider the inflation as well. So hurdle rate is also sometimes called as the minimum attractive rate of return, or there are some other terms such as the discount rate as well. So it is a engineering economic or financial term, which is very fundamental for every financial calculation. Is it understandable?
Thank you. Yes.
Professor, I'm sorry.
Yes.
Could you please change the 3% to 10 or, I don't know, 20 or 12, just to take a look what will happen?
Of course. This is Excel. We can check. Oh, what happened? Oh, I don't know. I have pressed some wrong key. Okay. Yeah. So 12%.
Yeah, something closer. Okay. To the reality.
Yes. Yeah. So yeah. So if, for example, here I can see that if the inflation has increased, so then the net present value has become a negative. Okay. So for larger the inflation, less and less will be the discounted cash flow. Then the amount of the worth of the money will become less and less. So it will happen like this. Okay, so now if this is one of the this is the case for a situation when we are taking everything for granted, but the things cannot keep like this. So just like as you mentioned that if we change the inflation rate from 3% to 12%, then the net present value will become negative. If we change the hurdle rate, if the hurdle rate also increase, then the net present value may also become a negative. So this we can see very easily over here. However, if we want to include some effect of the risk, so then we have to include the effect of the risk. Then we have at the very simple way is to include the effect of the risk by some simple calculations. For example, maybe if we can say that uh, uh, in this model, okay, in this model, if we can say that this $25,000 benefits which we are predicting in the following years are not certain. So this $25,000 is just an educated guess, but in reality, sometimes these benefits may be say $20,000. Sometimes these benefits may say maybe say $18,000, or sometimes maybe these benefits may be even less, like $10,000. Okay, so how to incorporate this uncertainty? So to incorporate into this uncertainty, we perform the Monte Carlo simulation. So for that Monte Carlo simulation is nothing but the random assigning of some values, and then these values are assigned like thousands of times. So for example, in the Monte Carlo simulation, in one of the iteration, for example, these benefits values will be assigned like for one time, and then for one time the net present value will be calculated. Okay, and then it will be assigned for another time, and then the net present value will be calculated. So maybe if we perform say like 1,000 such iterations, and the average of those net present values will be then calculated, and then from that type of analysis we can say that this many number of times the analysis was performed, and then that means 25% of the time the net present value was less than some amount, 25 and 75% of the time the value was greater than such an amount. So for this purpose we can use some add-in software. Okay, we can use some add-in software in Excel. So one of that add-in software in Excel is the ModelRisk. Okay, so I will illustrate. I'm going to illustrate it very briefly with ModelRisk software, and the other one is the Crystal Ball. Crystal Ball. Okay, and then maybe also there is another one is the at-risk as well. So. Another software is the at-risk, and then like there are some other software as well. So I'm going to illustrate it with the help of the ModelRisk. So ModelRisk is a software which works as an add-in to the Microsoft Excel. So maybe I can open it. You can first of all you can install the ModelRisk on your computer. But unfortunately now they are only giving as a trial software for 15 days. So I don't know what will happen after say 15 days. Will the trial work or not? I'm not sure. Okay, so now I have opened this model risk. So nothing will happen. It will only open in the Microsoft Excel. So I will go back over here and yeah, I will see a model risk tab which will open over here. So maybe I don't know. In my this Excel file, it is not showing it over here. Anyway, but I can copy this data into my new Excel, and then okay, so here I have this data now, okay, and I'm going to use the model risk. So in model risk, what I will be doing is that I will just apply this. I will use this data and then I will apply the simulation. So in this case, I can take various assumptions, but for simplicity and because now I have the time left for this lecture is very less, I can take the only assumption is that I can take the only assumption is that uh, that the annual benefits, that is these $25,000 amounts, annual benefits follow normal distribution and follow normal distribution with average with $25,000 average, $25,000 average mean, and about $5,000 standard deviation. Okay, standard deviation. The meaning of this is that sometimes in some of the year the value will be $20,000. In some of the year the value will be $22,000. Some of the year the value will be $27,000. So if you will take say something like these values like 1,000 times, so average of those values will be $25,000 and its average spread will be like $5,000. So this can be done in my model risk like in this way. Okay, so in this case I will I will click this model risk. As you can see, can you see model risk on the screen?
Yes, yes.
Okay,
Yes.
and then I will this is a very simple illustration. I mean this model risk software offers many more things which I don't have time to explain over here, but I will be just giving you very simple demonstration. So model risk, and then I will select the distribution. And in the distribution, you will see various types of distribution. Here I will find the normal distribution. Okay, so the normal. Maxwell, yeah, this is the normal over here. Okay, yeah, this will be also in some of the common distributions as well. So if now I want to select these values for the normal distribution, so I will select these values of the first one, and then select the distribution, and then I will go to the common, and then I will select the normal distribution, and then I will click OK. But in this case, I will provide the values of mu and sigma. Mu is the symbol for a mean value. So the mean value I want to say is 25,000. Okay, 25,000 is the mean value. And the sigma is the standard deviation. Standard deviation is say 5,000. Okay, and that's it. And then I will click this button, insert to the worksheet. So now you can see that the value has been changed over here. Okay, instead of $25,000, the value has been changed to like 32,460.5. This is a randomly generated value. Okay, with the mean of $25,000 and standard deviation of $50,000. So similarly, I will copy all these values over here. Okay, and by copying all these values over here, And then, oh, I think my um, uh, spreadsheet has been, maybe I can just copy this data from before. Okay, I can then copy it. Or maybe I can just find the net present value. I don't need these columns actually. I can just calculate the net present value by the inbuilt Excel function as well. So just ignore these values, okay? Just ignore these values. I can get the net present value by this. So for example, net present value will be, I can use this net PV, NPV, and here I have this. No, net present value I can use like, so the total of 15 and 3 is 18%, so 0.18, and then the values are this and plus the value in the first one. So it is plus 7,026. Okay, 7,026. This is the net present value. Or maybe I can just hide these values over here. Okay, so this is the net cash value. Okay, so after doing this, so what I have done over here is in the model risk, I have selected the distribution, and then I just copied these distributions over here, and then this is the formula for that, for the distributions. So and our next step is to perform the simulation. So for performing the simulation, first of all, I have to select the output value. So the output value is in this cell, okay? And then I have selected it, and then other values, other arguments are just very just optional. Okay, and then I will select the simulation. For the simulation, I will select the start button, and the simulation will be run, and then it will be giving you a message to me that I'm using a trial version. Yeah, I think this, I will need to wait for some time because this is something like 15 second, 2 second, 1 second, and then I click OK, and the result will be produced. Okay, so this result will show some data over here, and that this result will show some data over here. On you can over here you can see that by performing those 1,000 trials over here. So as you can see, 1,000 trials, we have obtained a mean value of the net present value of $1,974, and with the minimum net present value of minus $30,000 in one case, and the maximum value of $28,000 in one case. But the mean is 1,974, which is a positive. And over here, you can also see that the standard deviation is $7,610. Okay, so in this case, yeah, over here, the data you can see over here. Also from this histogram chart, you can see that on the x-axis, the net present values have been shown as a power of 10 to the power 4. So here it is showing the negative 0 net present value. So if I remove this slider over here, and then I read a percentage over here, it is showing as it is 41%. So what does it mean? It means that there is 41% chance, okay, there is about 41% chance that the net present value for this investment will be negative in this case, okay, which we can also see from the percentile columns as well. So 35% is minus 1150, 45% is 6840. So between 35 and 41.5%, the value is changing from a negative net present value to the positive net present value. So but from this histogram, we can simply see that it is at 41% chance. So due to this things, due to this data, so for example, if I want to input the data over here, so what the mean value of the investment I got is, and the standard deviation and the risk for negative net present value. Okay, net present value. So these three important data which I have got over here from here. So the mean value was 1974. Okay, the mean value is 1974. So 1974, which is positive, but the standard deviation is high. Standard deviation is 7610. Okay, 7610. And the risk for the negative, that is the probability for the negative net present value is 41%. Okay, 41%. Maybe I corrected. So that is the probability. Probability for negative net present value is 41%. So based on this data, will you accept this project? So the answer is most likely no, because it is too risky, because the probability is 41%. There is a 41% probability for a negative net present value. And the standard deviation is quite high as well. Although the mean net present value is positive, but it can also change very easily to the negative net present value. So this is a high risk project given this situation. Okay. So this was the result. Okay. So do you have any question about this? Hello? Hello?
Yes, Professor.
Do you have any question about this?
No.
Yeah,
No.
so in this case, so someone has asked that what will be the acceptable probability? Yeah, so the probability for should be high actually. It should be at least greater than 50%. Okay. So in this case, and another thing is the standard deviation is as well. Standard deviation, when the standard deviation is more than the mean, that means there is a larger variability in the data. So the project may not be very acceptable in this case. Anyway, so we have actually run out of time, and